Welcome viewers. Today we are going to see the term which is more often used in operating system, and that is critical section. What exactly critical section means? As word itself explanatory one. Section we can understand one part. Section means one part, and critical means the part which is very much important regarding that process to solve or to execute any program or any process. So that's why combining these two words we say critical section. But what exactly it is critical section means? Let's try to understand with help of examples. For example, if there are two programs or processes, they are executing their independent part by their own. At that time, there is no matter, there is no overlapping of resources. There is no common resources required in independent execution of their own programs. But when these two programs or processes demanding the same part of any resource, then problems may occur. How the problem occurs? Yes, we can understand that. Suppose there are two vehicles. One vehicle is coming from left side and one vehicle is coming from right side, and both are sharing one common road, and at the same time if they want the same road to cross the pool, to cross the bridge, then what will happen? Absolutely accident, crash of system. The same thing happened over here. The two processes demanding a common part of a resource, and it is impossible to allocate that resource to both the processes by operating system. So in this regards, operating system provides the solution and make that common part as a critical section part of the execution of that whole mechanism. Have you understand? Which becomes the critical section? Yes, not entire process or not entire execution. Which section becomes the critical? The section which is demanding by the two processes for the same time for their execution. That only portion becomes the critical. And to solve this critical section problem, operating system provides the solution. How the operating system provides the solution to solve these critical section problems? There are three conditions that we have to take into account while solving the critical section problem. Number one, mutual exclusion. Number two, progress. And number three, bounded weight. Before to understand these three things, first we are going to understand what exactly execution of any process or more than one process means. Suppose one program is executing. At the time of execution, the program is roughly divided into three parts. One part, that is entry level code, then critical section code, and last exit level code. And the same three parts we can apply for the second process. As per our discussion, if we compare or if we include that these three parts: entry level, critical section and exit level code for the two processes. Regarding the critical section, when one of the process of the critical section area demanding critical section, then what happened exactly? That process handles the entry level code in a smooth way and enters into critical section area. Means what? The critical section resource is available for process 1 because that process enters into entry level code and it executes that code safely, smoothly, successfully. That's why it enters into the critical section. At the same time, process 2 cannot enter into the entry level because code is written in such a way in the program in entry level. If one process, if it is in critical section, then the entry level code cannot give the permission to another process to enter into critical section. In this way, we can solve the critical section problem. At a time, only one process can use a critical section area to their execution. And these things means what? These things means a mutual exclusion. Means mutually the two processes understands if one able to crack entry level only can use critical section. Another process have to remain outside of the critical section and that process have to wait. What is this? This is mutual exclusion. And this is the number one method to avoid critical section problem. Number 2, progress. What is progress? Suppose we know that we have seen up till now any program having 3 parts: entry level, then the critical section and exit level. If one process able to successfully crack entry level can use the critical section area. At that time, another process cannot use the critical section part of any process or any program. But here in progress, what happened? One process who itself not interested to go into critical section, but that process make the interference, make the interruption to another process and it locks the entry level admission of another process. So the both processes cannot go into the critical section. As we know that the process number 1 does not have any interest to use critical section and that process create the interrupt to the process 2. So that's why both the processes cannot able to crack entry level code and cannot enter into critical section. So critical section area remains empty and this causes into the degradation or non-execution of both processes. And finally we can say there is no progress in the execution of both the processes. So to solve the critical section problem, here we have to avoid such problem and we want in any case progress of any process. So that's why this progress point is important regarding critical section. Number 3, weighted bound process. weighted bound. What is this? As we know that weighted bound means, or we can apply our logic to understand weighted bound. These two words itself explanatory. कि something binding is there, something restriction is there, and some weight is there. Restriction is executed according to the weight. It's something like this, as the word suggests. And yes, you are absolutely correct. What exactly it is? Bounded weight. For example, process 1 is able to crack entry level code and using critical section area for the execution of their program, their processes. And at the same time, process 2 is waiting for the critical section area as it is engaged by the process 1. As soon as when process 1 gets out the critical section area, obviously there should be the entry for process 2. But here what happened? Again process 1 cracks the entry level code and again enter into the critical section and use that critical section. Again what happened? Process 2 is waiting for critical section area as it is engaged by process 1. Next time again what happened? Process 1 comes out the critical section and again it captures the entry level code, successfully crack it and enters into the critical section. Process 2 again waits for the use of critical section as it is engaged by process 1, and suppose it goes on, and if there is no entry for process 2 in critical section, then that system is not good. So to avoid this kind of problem, there is solution given by the operating system regarding the critical section. After every particular turns, suppose process 1 is engaging 4 times the critical sections consecutively, then process 1 cannot enter into critical section. After 4 turns of process 1, then operating system gives the chance to the process 2 to enter into critical section, and this happens more and more times. Why this is so? Why such kind of arrangement? To avoid the monopoly of any one single process in execution of and sharing of resources in critical sections. This phenomena is known as bounded weight. So what we have seen up till now, what is exactly critical section? Number 2, 3 different methods or essential criteria required to handle critical section: mutual exclusion, progress, and bounded weight. Have you understand these things? Hope so. You have understand all these things. Thank you very much.